Okay, so here we go with solving word problems that use the normal distribution. Okay, so the example that I'm going to run through today uses a variety of different steps and procedures, so you need to kind of follow along. And of course, hopefully you'll get to view this as many times as you need to. So these are the steps, and I'm going to refer back to these steps as we need them. All right, so the first example, and I was going to get a little picture of a dog, but I couldn't find one that would run off nicely. These are adult male beagles, which are, you know, the beagle just won the Westminster dog show. And that's unusual, because he's like a breed that doesn't have to be groomed. Anyway, okay. So the weights of these adult male beagles are normally distributed with a mean of 25 pounds and a standard deviation of 3 pounds. Those two numbers are very important to your success in these problems, so you might want to write them down somewhere. The mean we call X bar, and that's going to equal 25 pounds. The standard deviation is 3 pounds. So just some information to keep in mind because you will need this for the problem. The first thing we are going to do is find the probability that the beagle's weight is less than 23 pounds. Okay, now what we don't have here, which you're used to seeing, is a z-score. So step one in this process is to convert this 23 pounds into a z-score. So here's the z-score formula. Have we talked about z-score formulas before? All right, well, this is an important formula. Z equals X minus X bar over S, where X is the value that you're converting, X bar is the mean that has to be given, S is the standard deviation that also has to be given. Okay, so we're going to end up with a z-score. Now, everybody knows what a z-score is. That's what we look up on the table. Okay, but we got to get to the z-score first. And so I'm going to do this little calculation. This will be 23 minus 25 over 3. Or this is 23 minus 25 is negative 2 over 3. If you convert this on your calculator, and you should, it will be negative 0.6, and you round it to the hundredths place, negative 0.67. Does anybody recognize that from the past as an important value in z-scores? We may end up talking about that at the end of this problem. But okay, so negative 0.67 is our z-score. Next step, I'm going to draw the curve. Now that I have a z, I can draw the curve and place it. Here's the curve. 0 in the middle. Negative 0.67 is very close to 0. And we want a less than. So I'm shading to the left. Next step is to look it up. Look it up. Look up the z-score. So on your negative side of your z-score table, okay, you go down to negative 0.6. And if you aren't familiar with the table at this time, you should be looking at how I'm doing this table. Down to negative 0.6 and over to the right so that you're under the 0.7. And this value, 0.2514, is the answer to the question. I'm going to write this in probability notation first. So probability that z is less than negative 0.67, then will equal that 0.2514. And that's our answer. Yes.
Oh, that's my phone.
So step one is to convert to a z-score. Step two is just like we've been doing before. Draw your curve, place your z-score, look it up, and the final, okay, so I've put step 3 is write the probability equation, and then use the table to find your answer in step 4. So 4 steps here.
Will we always have to give the answer with the probability and the answer following after it, or do you just want the number?
Well, if you've got some work to do here. If you are comfortable with the table, Unless you're asked to draw the curve, you don't have to. But as you work through this, I think that you need to take each step, including the probability step, and work it out at first. You know, after a little while, you'll get to where you are comfortable with it and can do it really quickly. Okay, letter B here, same situation with the dogs. We're going to find the probability that the weight is between 24.5 pounds and 25 pounds. Okay, so step one is to come up with z-scores. Now, this is a between. I need two z-scores. I need a z-score for each of these numbers. So I'm going to do this twice. I can just call it z1 for to keep it from being confusing. So 24.5 minus 25 divided by 3. And then the z2 will be 25 minus 25 divided by 3. Okay, this is going to be a z-score of 0. All right, that's obvious. This one is a little bit different, so we want to get the calculator out. 24.5 minus 25 is negative 0.5 divided by 3. And we need a decimal here, so we're going to do that division. Negative 0.5 divided by 3. Negative 0.17. Okay, always round to the hundredths place for the z-score. That's because that's what the table has the values in, to the hundredths place. So this is step one. Step two is to draw the curve. So we have a negative 0.17, very, very close to 0, and 0. So it's just this little area right in here between those two values. Right in between. So it looks like it's going to be a very small probability, because we're very close to 0 and right up to 0. Okay, so step 3 is I want you to write a probability equation so that you're used to it. So this is going to be negative 0.17 is less than z is less than 0, just like that. So that's just our between written as a probability equation. And now we're going to look up the two values. Remember that we have to look up both values and then do a subtraction because it's a between. So when we look up negative 0.17, okay, so you should have your table in front of you. It'll be more clear than this is. Negative 0.1 is at the very bottom of the table, then over to under the 07, and that's 43.25. So our first value, and I'm going to write it here because this is where it's located. That is this area right here, up to negative 0.17. Okay. What's 0 going to be? Yeah, it's half the graph, so it's going to be exactly 0.5. So all the way over half the graph is 0.5, and that's too much. So we have to subtract these two to get the final answer. So it's the negative 5,000 minus the 0.4325. Do a little subtraction. And we get 0.0675 as our probability that the weight of this randomly selected beagle is between 24.5 pounds and 25 pounds. So that's saying that about 7% of these dogs weigh between these two values. Okay, so the probability of randomly selecting one is this amount right here. Okay, so we've done a less than, we've done a between, now we're going to do a more than. Same situation, same mean and standard deviation, same steps. Step 1, write a z-score. So this is the probability that the beagle's weight is more than 30 pounds. I only need one z-score here for the 30 pounds. So 30 minus 25 divided by 3 will be 5/3. We convert this into a z-score, so this would be 1.67, always round to the hundredths place. You know, with this table being so precise, if you don't round this and you look up 0.66 instead of 0.67, you're going to have a different number. So you need to make sure that you're rounding properly to the hundredths place. All right, so step 2 is draw the curve. This is greater than 30 pounds or greater than the 1.67. We're shading this way. Probability equation, z is greater than 1.67, simple as that. And now all we have to do is look up. We actually have a couple of ways to look this up. The way that I taught you at the beginning of this, before you were really accustomed to the table, is to look up the 1.67, 1.6, and over to the under the 7, and you get 95.25. Well, that's way too much. That's all of this. So we did learn that you can, when you do look this up, and this is the value that you get, you know that's too much. So to get the answer, we just take this and subtract it from 1. So 1 minus the 0.9525. But I want to show you something else. And we've discussed this, and a lot of you have already figured this out, that because of the symmetry involved with the normal distribution, it's perfectly symmetric. If this area that's shaded in is 0.475, then the area on the other side that's at negative 1.67 is the same amount, 0.0475. So if you're doing a greater than, a positive value, a positive z-score, you could look up the less than a negative z-score, and it should be the answer that you're looking for without having to subtract from 1. But the only reason it is because of the symmetry that's involved. So let's look over at the negative side of this. The negative 1.67, because that's perfectly symmetric from the positive 1.67, is 0.475. Perfectly symmetric, and that will help when you get to, you know, it'll alleviate a step if you understand that symmetry. If you don't get the symmetry, just go ahead and do your subtraction from 1, and you know, the more of these you do, the better you get at recognizing the symmetry when it happens. Okay, so any questions so far? You're doing okay so far? Yeah. If you're comfortable with the table, you should be able to do these extra calculations pretty easily. All right, now letter D says, are any of these events unusual? Okay, so we've done 3 of them here. Are any of these unusual? We had a 0.25, we had a 0.06, and now we have a 0.0475. Which one's unusual? The last one, the 0.475, and why? Yeah, so 0.0475 is less than 0.5, which is our cutoff for unusual events. So if the probability is less than 0.05, then we say that that event is unusual. So it would be unusual to find a beagle who weighed more than 30 pounds. Pretty close to being right on it, but it's definitely unusual. All right, we're sticking with the beagle, and I've got some more questions about it. But these are more like what we learned about last time, or a couple of classes ago. We're now looking at determining what the top 10% of the beagles are in their weights. So this says that a beagle that weighs in the top 10% is considered overweight. So, but we don't know what that number is. Okay, so that number is based on the mean and the standard deviation that we have. So the question is, what weight separates the bottom 90% from the top 10%. Okay, well, I put it in this wording like this because that's the way the book does, and it kind of gives you an idea of what the curve should look like. So when I draw this curve, remember in drawing this kind, we're looking at 100% down here, 50% in the middle, and 0% to the left. Okay, so when I say separates the bottom 10%, 90% from the top 10, I'm going from left all the way over to the 90% here and 10% here. So I want to know what is the Z that goes there. That is the question. What is the Z that goes there? So this is where we have to look up from the middle of the table out to the Z-scores. So I'm going to look up 0.9000, or as close as I can get to that 0.9000 on the table. So if you look at your table, there's smaller numbers on the negative side, so this is a positive, which makes sense for where that's located. So on the positive side, we're looking for the value closest to 0.9000. 8997, I agree. And actually, we talked about a little bit about this, recognizing some of these frequently used Z-scores. This is positive 1.28. So from the 8997, which is as close to 9,000 as we can get, go out to the left and it's 0.2, up to the top it's 0.8, so that's positive 1.28 is our Z-score. And some of these you're gonna learn to use to recognize, and you'll just know immediately that anything in the top 10% is going to be 1.28. What would the bottom 10% be? Negative 1.28. Again, the perfect symmetry. So the questions will kind of lead you to start understanding those ideas. Now, we're not even close to having an answer yet. We still don't know what that Beagle weight is. So we're going to continue to use the Z-score formula, but we're going to use it differently in that we're going to solve for X this time. So here's the formula. I have a Z. So I'm going to put 1.28 on the left side of the equation. X stays there because that's what I don't know. This will be minus the 25 pounds divided by 3. Okay, so we end up with what is just a really simple algebra equation to solve. Okay, we're solving for X. What's the first step here?
Multiply.
By
3? I don't know.
Okay, you can't see it. It's a 3.
Yeah.
Okay, so we're gonna multiply both sides by 3. You're right. Or I like to just think of it as cross multiplying. I'm going to cross multiply by that 3. So 3 times 1.28 . It's very important that you're careful with the signs, negative and positive signs here in this kind of problem. So X minus 25. Now what's the next step? Add 25 to both sides. So we're adding 25, and this is 25.00. So 28.84 pounds is the cutoff for beagles, determining which beagles are overweight. So a beagle that weighs 28.84 or above pounds is considered in the top 10% of weights and considered an overweight beagle. Okay, so the last one is I'm going to make a change to this last question. Okay, I say find the beagle weight at the first quartile, but instead of asking for the first quartile, I think I'll ask for the third. Okay, third quartile. Now, whenever you are finding an actual weight or an actual number in the data set, you're doing the, and you're given a percentage, and that's what a quartile is, it's a percentage, you have to do the curve first. That's the first step. So if 100% is out here, 50% is in the middle, what is quartile 3? What percent is quartile 3? It's 75%. This is the third quartile. So it's out here somewhere at 0.7500. So the question is, what is this Z? I want to know what that Z-score is for 7,500. So it's important that you locate what you're looking for here. Okay, so quartile 3 is 75%. So from left to right, we're stopping here. We want to know what that Z is. So again, I'm going to go to the table. Looking up the closest value to 7,500. 0.7500. 49, 7486. And 7517. So the 7486 is the closest one. And that's positive 0.67. All right, do you remember that the quartiles were 67.67? And what's the first quartile then? The Z-score for the first quartile? Negative 0.67, right. All right, now and I'll tell you in a moment why I changed this. Okay, so we still need to find that weight. Okay, so this is just the Z-score. And that's why these problems become a little more complicated, because before we were stopping at the Z-score. That was our answer. Now we have to go on and find an actual weight. So I'm going to use the formula again. This formula at the top here. Okay, so Z I have 0.67 equals X is missing minus 25 divided by 3. Multiplying 0.67 times 3, we get 2.01 equals X minus 25. Adding the 25, we get 27.01 is at the third quartile. And that is a weight, so that's in pounds. So 27.01 pounds is the vehicle weight at the third quartile. So let's review what we did. Back to the first problem, and this is why I changed it, because we got a Z-score of at the first quartile in the first problem. I didn't even realize we would do that. Hadn't run through this problem yet, and we got through. So this is the beagle weight of 23 pounds is at the first quartile. So I didn't want to do that problem, reverse that problem. So we did a less than, we did a between, we did a more than, then we answered an unusual or not question. Then on the second page, we went the other direction, going from the body of the table out to the Z-scores to find the top 10% weight and to find the third quartile weight. So these are the procedures that you have to use for all these kinds of problems that are assigned today. Should be the same procedure each time, and the more you get accustomed to it, the easier it becomes. And definitely gives you more practice with that table, and knowing how to use that table properly will make this process a lot easier. I do want to point out that I believe that this Z-score formula is on your reference sheet. So that is another formula that is there on your reference sheet. You don't have to have it necessarily in front of you. You'll get to where you memorize that formula. It's one of the most common formulas we use.
What kind of problem was C? There was a less than, more than, and C was a...
Okay, letter C was a more than.
Okay.
It was B was a between, A was a less than.